Welcome back to the deep dive. Today, our mission is to explore a mind so fundamental to our world that we almost forget he was a real person. We're doing a deep dive into the sources on Sir Isaac Newton.
And when most people think of Newton, it's the apple, right?
Yeah.
Gravity. But that picture is just so incomplete.
Wildly incomplete.
The sources show us a scientific revolutionary, a fiercely private theologian, an obsessive alchemist, and even, surprisingly, a ruthless public servant hunting criminals.
Right. We're going to peel back that scientific curtain to get at the full, complex man, the mathematician, the physicist, astronomer, inventor, and crime fighter.
He was a cornerstone of everything. The scientific revolution, the Enlightenment. I mean, the praise for him is just astronomical.
It really is. He's been called the most influential figure in the history of Western science.
And the mathematician Lagrange said he was the greatest genius who ever lived. To hold that reputation for 300 years, well, we need to figure out how he earned it.
So let's unpack that. Where does a mind like that even begin?
Well, it was a completely unpromising start. He was born prematurely, Christmas Day, 1642.
In Woolsthorpe, right?
That's right. And according to the stories, he was so tiny, his mother said he could fit inside a quart mug.
Wow. That's a powerful image. And the adversity didn't stop there. His father died before he was even born.
3 months before. And then his mother remarried, and young Isaac, well, he did not get along with his stepfather, the Reverend Barnabas Smith.
That's putting it mildly.
It is. I mean, we have this early list of sins he wrote as a teenager, a kind of moral inventory.
And in it, he lists this really chilling entry.
It's right there. Threatening my father and Mother Smith to burn them and the house over them.
That is genuinely shocking. It shows such an intensity, a kind of volatility you just don't associate with the calm philosopher we see in portraits.
It points to a really difficult adolescence.
Yeah.
And he hated farming, which his mother tried to push him into.
He was a failure as a farmer.
A total failure. His mind was already elsewhere. He gets at Trinity College, Cambridge, but even there he was, kind of unremarkable student until, that is, the world shut down.
The Great Plague, 1665, the university closes.
And Newton goes home to Woolsthorpe. And those next 2 years of just solitary study have been called the richest and most productive ever experienced by a scientist.
So in his early 20s, working alone, he lays the foundation for, well, everything.
Calculus, optics, and of course his initial thoughts on universal gravitation. It's just an unbelievable explosion of intellect.
What drove that? Was it just raw intelligence?
It was that, but also a unique kind of structural thinking. He's been described as an exceptionally organized Janushan thinker.
Okay, what does Janushan thinker mean here?
Janus, the Roman god, had two faces, one looking forward, one back. For Newton, it meant he could hold two totally separate ideas like pure math and physical observation in his mind at the same time and just synthesize them.
He didn't just study them, he married them.
Exactly. And that marriage produced his masterpiece, the Principia Mathematica, in 1687.
Which was basically the instruction manual for the universe.
It was the first great unification in physics. He takes one force, gravity, and with his laws of motion, he explains everything. Planetary orbits, the tides, comets, the wobble of the Earth's axis.
And what was the immediate impact of that?
It ended the debate. It mathematically proved the solar system was heliocentric. It put everything, the sun, Earth, Jupiter, on the same measurable gravitational scale. He turned the cosmos into a solvable math problem.
That all sounds so objective and pure. But his career wasn't without conflict, was it? We have to talk about the calculus war.
Oh, the priority dispute with Gottfried Leibniz. And this wasn't some polite academic disagreement. This was a bitter international feud that lasted for decades.
So Newton developed his version, fluxions, back in the plague years, starting around 1664.
Right, years before Leibniz published his work, though everyone now agrees they developed it independently.
But the fight got public and ugly around 1711.
Very ugly. Newton, by then, is the powerful president of the Royal Society. And the society convenes a committee to decide who was first.
And, surprise, surprise, they rule entirely in Newton's favor. They basically call Leibniz a fraud.
And here's where Newton's dark side really comes out. This is just, it's jaw-dropping. Later scholarship revealed that Newton didn't just accept the verdict.
What did he do?
He personally wrote the study's conclusion. He used the most powerful scientific body in the world to publicly brand his rival a plagiarist.
Wait, he was the judge and jury in his own case?
Essentially, yes. It was a secret act of sabotage. It created a huge rift between English and continental mathematicians for decades.
That's an incredible abuse of power. And yet his contribution to pure math, beyond just calculus, is still
Oh,
immense.
it's overwhelming. The binomial theorem, numerical integration,
Mm.
he basically invented vector analysis by giving us the concept of a vector for things like force. He changed the whole game.
Okay, let's move from the abstract to the physical. Light. His work in optics was just as revolutionary.
Absolutely. His 1666 prism experiment. It seems so simple now, but he showed that when a prism splits white light into a rainbow.
The color isn't being added by the prism.
Exactly. The color is intrinsic to the light itself. A monumental discovery.
And that led him to a practical invention, because he realized traditional lenses had a flaw.
Chromatic aberration, the color fringing you get because different colors of light bend differently. So he just bypassed the problem. He built the first functional reflecting telescope, the Newtonian telescope. He uses a mirror, not a lens, so there's no color distortion. Just brilliant practical engineering.
And here's where it gets really forward-thinking. He's known for his particle theory of light.
The corpuscular theory, yes.
But in his book, Optics, he sort of hedged his bets.
He absolutely did. He described phenomena that only made sense if light also behaved like a wave. He basically said it had both particle-like and wave-like properties.
So he anticipated wave-particle duality, a core concept of quantum mechanics, almost 200 years early.
That's what many physicists would argue, yes.
Right.
It just shows his ability to observe what was there, even if it contradicted his own favorite theory.
And he even pioneered a kind of early data science.
He did. In his work on Newton's rings, he came up with what he called an error-slaying method. Instead of one measurement, he averaged the differences between many measurements to reduce the noise.
That's basically regression analysis in the 17th century.
Unprecedented. He wasn't just finding the laws of the universe. He was writing the rules for how to do good science.
And he even figured out why a spinning tennis ball curves.
The Magnus effect. He described it perfectly almost 2 centuries before it was formally studied. He said the spinning side presses and beats the contiguous air more violently.
Creating a pressure difference. So every time you see a curving free kick, you can thank Newton for the explanation.
And now we get to the part of his life that feels like it belongs to a totally different person. This rigorous mathematical mind spent at least half his life on 2 secret, intense passions.
Radical theology and alchemy.
The ultimate contradiction. The economist John Maynard Keynes bought many of his papers and called Newton the last of the magicians.
Let's start with his faith. He was a devout Christian, but secretly very unorthodox.
Extremely. He completely rejected the doctrine of the Trinity. He believed that worshiping Jesus Christ as God was idolatry, the fundamental sin.
Which was a hugely dangerous belief to hold back then.
Oh, he was heretical. If it had become public knowledge, he would have lost everything. His position, his reputation, so he hid it perfectly.
And then there's the alchemy. Our sources say 1 million words of his papers are about alchemy.
He was completely obsessed. Searching for the philosopher's stone, the secret fire of nature, he was in his lab constantly working with dangerous stuff.
And that likely had physical consequences.
Almost certainly. They found high levels of mercury in his hair after he died, probably from inhaling fumes during his experiments.
Which might explain some of his later eccentricity and that nervous breakdown he had in 1693.
Exactly.
Yeah.
It gives a physiological reason for some of that behavior. He was literally being poisoned by his secret passion.
Okay, we have to talk about the toad cure. This is the detail that just blows my mind.
Right, from his notes on the plague in 1665. While he's inventing calculus, he's also looking for cures. And he writes down what he thinks is the best one.
And it involves a toad.
It involves hanging a large toad in a chimney by its legs for 3 days until it dies. Then you powder the toad, mix it with its own excretions, and form the paste into lozenges to wear on the afflicted area.
The same mind that gave us the law of universal gravitation was also recommending a chimney-dried toad amulet.
It's the perfect illustration of the man and the era, the birth of modern science right alongside these deep, esoteric traditions.
And his personal life was just as intense, never married, a vegetarian later in life.
Incredibly disciplined. The work on his lunar theory was so complex it gave him headaches and kept him awake at night. He really did live inside his own mind.
So if alchemy was his secret life, his third act was completely public and just as surprising. In 1696, he moves to London to run the Royal Mint.
Master of the Mint. And this was usually a kind of do-nothing honorary job. But Newton attacked it with the same intensity he applied to physics.
His first big task was dealing with counterfeit coins.
A massive problem. He estimated that 20% of all the coins in England were fake. It was a national economic crisis.
And he didn't just sit in an office, did he? He went out and became a detective.
He did. He went undercover. He'd hang out in London's worst bars and taverns, disguised, just listening and gathering evidence on the coiners himself.
I cannot picture Isaac Newton in a wig, sitting in a smoky pub trying to get tips on counterfeiters. It's an amazing image.
He even became a justice of the peace to give himself the power to prosecute. He personally cross-examined over 100 suspects. He successfully prosecuted 28 of them, including the most notorious counterfeiter in England, William Challoner.
And Challoner was hanged.
He was. Newton was a ruthless crime fighter, but he also had a huge economic impact.
He improved the minting process itself.
Dramatically. He standardized the weight of the gold guinea coin, which saved the treasury a fortune and restored public faith in the currency.
And then, almost by accident, he put Britain on the gold standard.
He did. His 1717 report on the ratio between gold and silver inadvertently made silver undervalued, so gold became the de facto standard, a system that dominated global economics for more than a century.
What a life! From a premature baby who hated farming, to the man who defined the universe, to a crime-fighting economic reformer.
Knighted by Queen Anne in 1705, and when he died, he was the first scientist ever to be buried in Westminster Abbey. A true national hero.
It makes sense why Einstein had a picture of Newton on his wall. Einstein said Newton's work was perhaps the greatest advance in thought that a single individual was ever privileged to make.
Which brings us to our final thought. Newton's public mantra for science was, frame no hypotheses. Hypotheses non fingo. Don't build theories without direct, observable evidence.
Right. That was the rule book for the new scientific revolution. Pure empiricism.
Yet this same man privately spent decades of his life obsessed with alchemy, a field built entirely on secret knowledge and occult qualities that could never be observed or proven mathematically.
Incredible contradiction.
So, we'll leave you with this. Given that stark contrast between his public philosophy and his private passion, what does that tension tell you about the true, unseen curiosity that drove the greatest scientific mind the world has ever known?